All right, welcome to this YouTube video on factoring trinomials. And these are the more complicated trinomials whereby which we have a is not equal to 1. And so we have some value greater than 1, usually 2, 3, 4, 5, whatever the question happens to be. And there are two methods for solving these. The one is to do it by grouping, which this is what the video lesson that I'm going to do on right now is. And the other one is on factoring trinomials using the T method. So if you want to watch that video after this one, you can, or if you would just like to learn that method, you can. You can use either method. It doesn't really matter to me. Okay. Now the answer, the way these ones are solved is we take the A value here and we multiply it by the C value. That's what we call A times C. And then we use addition or subtraction to find the B term. And it's addition or subtraction based on the value of the C term. So in the very same way we were doing the other questions, okay? And then we separate the question out and we separate it into two, and then what we end up doing is factoring by grouping from that point forth. Okay, so as an example, here's a completed solution, but I'll just kind of explain how it went. So what I did was I took 3 times 6 to get 18. And then I said factors of 18 that add, because this is plus, to 11. And those were 2 and 9. 2 times 9 equals 18, and 2 plus 9 equals 11. And so what we did was we just put the 2x here and then plus 9x. So we broke this 11x apart into two parts, 2x plus 9x. And you could have written it actually 9x plus 2x. It really doesn't matter which way you go. It will work either way. And then what we do is we separate it down the middle. We factor the first part. In this case, we factored out an x. So we got x times 3x plus 2. And then over here on this side, we factored out a 3 to get 3 times 3x plus 2. And that allowed us to do factoring by grouping, which gave us 3x plus 2 times x plus 3, the x plus 3 coming from here and here. And that is our factoring by grouping, okay? And then we ended up with our answer, and you can multiply that through. So let's do a couple of examples here, and you'll see that it works pretty well. And I'll write my thinking down as I go, but this isn't necessarily what you have to do. But I would typically kind of go like this and go 12. 3 times 4 is 12. And so then I'm looking for factors of 12 that add to 8, and that's 6 and 2. And so then what I do is I go 3x squared plus, and I can say 6x or 2x, it really doesn't matter. I'm going to choose 6x this time, plus 2x. So I split the 8x apart into 6x plus 2x, and then plus 4. Okay, now this is set up beautifully for a factoring by grouping question. So in this case, I'm going to factor the first half and the back half separately. So here I see that I can factor out a 3 and I can factor out an x. So I factor out the 3x, and that leaves me with x plus 2. Okay, and then on this side, I look and I see what can I factor out? Well, I can factor out a 2. And so that gives me plus 2, x plus 2. And of course, the x plus 2 repeats itself. So now I can use factoring by grouping here, and I get x plus 2 times 3x plus 2, and I have completed my factoring of my trinomial. I've factored it into two multiplying binomials. Remember, factoring always is, it ends up being turning it into a multiplication question, and that's exactly what we've done here. Let's go through a couple more examples just so you see some different scenarios, different situations along the way. Here's another one. In this case, we have, again, 3 times 4 to give me 12, but this time I have a negative sign, which tells me that this here must be a difference. So now I'm looking for factors of 12 that have a difference of the middle term, which in this case is 1, and that answer is going to be 3 and 4. So if I want to make this into a 3 and 4, I have to say plus 3 or plus 4, sorry, minus 3. So if those two will multiply to give me 12 in this case, and they will add to give me 4, or 1, sorry, I apologize, 1. 4 minus 3 is 1. Okay, so what I do is I write it out as x squared plus 4x minus 3x minus 4. Okay, now what I'm going to do is I'm going to factor by grouping. So I'm going to split it down the middle. What can I factor off the front here? Well, I can only factor an x because 4 and 3 don't have any common factors. So I end up with x times 3x plus 4. And then over here, there's no common factors, but I have this negative thing here. And so what I'm going to do is I'm going to factor out a -1. And this is common if there's nothing. I don't want this number here in the bracket. I want it to be positive so that it matches up with the 3x over here. So this is a common thing that has to happen. I have to pull out a -1. So when I pull out a -1, I divide both of these by -1, and I end up with 3x plus 4 again. Because remember, the -1 is coming out of the 3x, but also the -4, because -1 would multiply back in again. Now you'll see that I got 3x plus 4, and I got 3x plus 4, so I can factor by grouping to get 3x plus 4 times x minus 1. And I'm done. I've completed the question. Okay, let's do one more example. This time, what I've got here is I've got a +1 and 6. So when I bring those two together, I get 6 times 1 is 6. And I'm looking for factors of 6 that add to 5. And I know this is negative, but when I have a positive here, I'm still looking for adding. The difference is now both of these are going to be minuses. So, you know, both are going to be negative when I do my final answer. So I see that it'll be 3 times 2 would give me 6, and that will add together to give 5. But in this case, it's going to be -3 and -2 would add to give -5. So I end up writing 6x squared minus 3x minus 2x plus 1. So all I've changed is this middle term in here. It went from 5x to these two terms, okay? And again, I could write it either way. It doesn't really matter. I wrote the 3x here and then the 2x here, but it doesn't have to be that way. I could have put the 2x here and the 3x. You'll still get the same answer, okay? It'll look a little different in your solution, but it will get the same answer. In fact, if you want, I'll do it right over here. Let's do it here. Let's do minus 2x minus 3x plus 1, and you'll see how they end up working out to the same thing. I just switched the order of those, okay? Now, what I'm going to do is factor out here. Well, I can factor a 3 out and an x. So I get 3x, and I end up with 2x minus 1. And on this side, I'm going to factor out a negative because I have a negative there, okay? So I'm going to factor out a -1, and that's going to give me 2x minus 1 again. And that way, these two are the same in the brackets, and that allows me to do factoring by grouping. So I get 2x minus 1 times 3x minus 1. And I'm finished. I've got my question done. Now I'll do it again over on this side, and you can just see here it works out to the exact same answer. In this case, now what I'm going to do, if I was just did it the other way here, I can only factor out a 2 and an x. So I get 2x, which leaves me with 3x minus 1, okay? And then on this side, I'm going to factor out a -1, which is going to give me -1 times 3x minus 1. And a lot of kids, well, how come that changes to -1? Well, when this minus 1 that you're factoring out, it divides by the 3, but it also divides by the 1, and that changes the sign when we divide by -1. And conversely, if this multiplies in, it's going to become +1 when it multiplies in. So we got to make it so it'll be the same thing. And then finally, I'm left with 3x minus 1 times 2x minus 1. And if you look, that's the same answer as over here. It's just written in reverse, but it is essentially the same because remember, 3 times 4 equals 12, and so does 4 times 3. So it doesn't really matter which order we write them in. That is factoring trinomials using grouping. And there is another video lesson on using the T method. Here it is down below. Please look that video up, factoring trinomials using the T method, and you can learn that method as well. I kind of prefer that method. I find this one a little clunky, a little more going on and more opportunities to make errors, but it is kind of more mathematically correct. You can choose which method you like to use. My experience is that, as kids go on in math, they almost always end up gravitating towards the T method. And so why not just learn the T method off the bat and go that way? It's up to you though. Either method works perfectly fine. All right. Hope you enjoyed the video, and see you next time.